G'day and welcome to Mark and Sam After Work. Today I want to start a new video series. This is called One Question at a Time. What it is answering exactly that, one of the many different questions we get on the basically comments largely, but all over the place we get all sorts of questions, and these are going to be short videos to answer those specific questions in as simple a form as I can. This one is about Coriolis. The question comes in many forms, whether that's is the Earth spinning, is the Earth flat, is the Earth a globe, is the Earth stationary, do you allow for Coriolis, does Coriolis affect your shot, how can you do things with Coriolis because it must be so hard to work with, and all those bits and pieces. I suppose I'll answer it and break it down into the questions that it is. Does Coriolis exist? Yes, it does. Coriolis exists. It's very, very simple. Hard to understand, but simple maths about something traveling away from the surface, but over the surface of a rotating sphere. It is simple maths, and yes, it does exist. Do I allow for Coriolis? The truth of it is, you really don't have to allow for Coriolis in any shooting instance. There's not enough time, there's not enough distance that a projectile can accumulate through the travel of a shot to make enough difference. And I should say, if we had perfectly still conditions, so the air wasn't moving things around, there wasn't wind and things like that, then yes, you'd be able to use Coriolis in a real sense. But when you understand that 1 mile an hour or a couple of k's an hour of wind can make more difference than Coriolis can make to the shot, then you understand that the wind is the big enemy here. Understanding that wind and then factoring in for the wind is the big deal. If you knew your perfect wind, exactly what you had, then once again you could use Coriolis. But as a shot travels through different winds on extreme long range shooting, particularly different heights, different locations, different winds, once again, it affects it more. So you really don't have to allow for Coriolis. You can factor it in, but the truth of it is you can never actually prove it because it is too small a difference. Now, to explain that, what is Coriolis is the easiest way to explain why that is. How can you say something's real if you can't prove it? Well, you prove it by the maths of it. And that actually comes from the simple understanding of what Coriolis is. The easiest way I can describe this is Coriolis is it's the effect that happens from that can be described in a simple way a differential in a car works, and that is when a car goes around a corner, so it's going around an arc, it's turning around a corner, the inside wheel and the outside wheel have to travel at different speeds because the outside wheel has to travel further than the inside wheel. If you have a lock diff, if you've ever been a place where there's a lock diff, so the two rear wheels or the driving wheels travel at exactly the same speed, as you go around a corner, particularly a tight corner, it'll either jump because it's on bitumen and it can't do it, or it'll squeal because it's skidding a wheel, or on dirt you'll find it'll be dragging one wheel or carrying one wheel because it's got to travel at different speeds. The different circumferences, so there's a different amount of travel as you go around a corner. That is basically the simple maths that goes with Coriolis. To explain it a little bit better, when we're talking about our globe, you can imagine that if you're sitting on a place on the planet, standing on a place on the planet, and you manage to fire a shot straight up in the air. If it's dead straight and there's no wind, what should happen is it's going to go straight up and turn around and come straight back down. So that all makes perfect sense as long as you're not moving. When you understand that it's all rotating around, the whole world is rotating around, the atmosphere is rotating with us. It's at the same speed. It's not the globe doing 1,000 miles an hour as our circumference speed of the globe rotating and the atmosphere staying still. No, it's traveling with us. But as you can imagine, when you do this same thing of understanding different circumferences travel at different speeds, the surface speed is traveling as it goes around at this speed. If you go up 2 miles in the air, it's traveling a slight bit faster. It's only a little bit faster because you're talking about the circumference of the Earth is around the 13,000 kilometers, so it's coming up into the 8,000 miles, 9,000 miles. You only go up 2 miles, you've only gone up by 0.1%. So it's only a small difference, but it's a difference. It's a measurable difference. So as you go up, travels at a different speed, but there's nothing attaching that. So if you stand on the planet and you shoot straight up, it goes up, you're moving away, it comes back down to a different spot. So it's the same spot that it's shot from, and you look at it like that. In actual fact, because it would have to travel faster to come back down with you, that's the difference we're talking about. Once again, this is traveling at 1,000 miles an hour, and this is not traveling at all. What I'm actually saying is that this is traveling at 1,000 miles an hour, and that would have to be traveling a tiny bit faster. That's what caused that bullet to come behind. That also means when you're not shooting straight up and down, you're shooting in one direction, whether it's east or west. In one direction, you're going to shoot and it's actually going to fall a bit short because you've moved closer to it. In the other direction, it's going to fall a bit long because you've moved further away from it. So that's the first and fundamental engineering or maths of Coriolis. The other difference is that as you go from, if you look at the globe side to side, if you've got the North Pole and the South Pole and the equator, either way, as you roll off the equator and down, you're shooting to a different circumference. Once again, that's a different speed. So where your speed is going to change is part of your left and right factors of Coriolis. So those are the ingredients that we're actually talking about. The maths gets a lot more complicated to understand, but it's all driven out of that same simple maths to start off with. So, but as I'll come back to, because it's such a small difference, because it's actually a percentage difference in the circumferences, and because it's also irrelevant to time, the more time it's at that different percentage, the more time it's going to then need to have more speed. Same as when you're going around the corner in a car with a locked diff. If you've only got a little adjustment to make, you're not really going to notice it. If you've got to turn right around or do 360s, it's going to make a lot of difference because of the time difference between those. The amount of time traveled, the amount of distance traveled, the more it's going to show up. So with bullets in particular, where we have firing even and the really long shocks, if you're getting up to 15 or 20 seconds, it's only a certain amount of time at those different heights which is relevant to your shot, but it's such a small percentage difference and the wind has so much more effect that you really cannot factor it in. You cannot allow for it in any sense, which is really accountable in a rifle shot. It is only just measurable when it comes to in a artillery. But once again, the weather, the wind can have more effect. So I won't get more complicated than that, but it is not something that the argument of, well, how can a helicopter hover? How can things travel in our, the atmosphere is traveling with us. So effectively, it's all staying at the same speed. It effectively behaves a lot like the world is stationary. It isn't the case. It's all rotating together. Yes, it's doing 1,000 miles an hour, but you go up 2 miles, it's doing 1,000 miles plus 0.01%, and that's the difference we're actually talking about. So I hope that didn't confuse things too much more. Yes, Coriolis is real. Really, no, you don't have to allow for it. And if you could get a perfectly still day, a perfectly stable day where you could really factor in the wind perfectly, if you ever find that, let us know. I'd love to be there and then be able to prove things. But the truth of it is, proving that your wind is either dead stable or dead still would be harder than proving Coriolis. So it is a factor, but like I said, it's something that largely you don't have to allow for. And the last bit I'd say on that, it doesn't change. If you're shooting that spot, your Coriolis is the same thing. It isn't a moving thing in the fashion of is it going to change and vary from shot to shot. It's always the same. So once you've seen your first impact, you're away and racing anyway. Hope that makes some sense. That's just the first of this one question at a time. Hopefully that's the longest one. It's a hard one to go through and try and explain, but that's the mass of it. That up and down thing, where you moved away, it's come to a different spot. That's the thing you're talking about. That's the engine. That's the thing that is Coriolis. Anyway, guys, thanks for checking in. We'll catch you next time.